Okay, so we're going to look at section 3, which is going to be dealing with um, space figures. So there's a sketch of a three-dimensional figure that contains 54 small cubes. If the outside of the figure is painted and the figure is disassembled into 54 individual cubes, how many cubes will have paint on one face, two face, three face, and no faces? So this is a big problem that comes up on a lot of math tests, math problems. It's interesting. Like, how many could you do? So what deals with when you talk about space is you're dealing with 3D figures. So 2D was lines, angles, polygons, right? In 3D, there's infinite number of planes. So each plane partitions into three disjoint sets, the points on the plane and two half spaces. So two planes are parallel or they intersect or they're not. So the best thing for planes is like the floor and the ceiling and the walls. So the floor and the ceiling are parallel and you know, the floor and the ceiling are parallel. Okay. And so when they come together, they meet at they make, when two parallel lines intersect, they form a line. Okay. So here's a content standard: strong sense of spatial relationship and who master the concepts and language of geometry are better prepared to learn number and measurement ideas as well as other advanced mathematical topics. So we were talking about right here, when two planes intersect, we call the angle between them the dihedral angle. So in figure A here, you have the line, the two planes intersect, they make a line. And then make a 140-degree dihedral angle, and there's a 91 and a 55. Okay, dihedral angles are measured. A dihedral angle is measured by measuring the angles whose sides line the planes and are perpendicular to the line of intersection of the two planes. So not too much to worry about there. I think that's pretty simple. So in A, you have an obtuse, B is right, and C is acute. So just like regular old angles, dihedral angles have those same type of names as well. All right, so you have three dimensions. When the line M in three-dimensional space does not intersect a plane, it is parallel to the plane. So it's just like floating above, okay, like in figure A. Then when a line N is perpendicular to a plane at a point, so a plane comes through, or a line comes through a plane, it is perpendicular at a particular point, like in figure B. Now the fun stuff, the polyhedra. So polyhedra is a three-dimensional object with flat sides. The best example of a polyhedra would be a soccer ball. You ever look at a soccer ball? It has a polygon for a face. All right. This has got 12 flat pentagonal sides, but the straight edges were not cut by people, but were shaped by nature. The surface of the figure in this space whose sides are polygonal regions, such as this figure, is called a polyhedron. Polyhedra is plural. So polyhedron regions are called faces. They intersect in edges and vertices of the polyhedron. So when you mix some things together, like the union of a polyhedron and its interior, it's called a solid. Right? The figure in part A is a polyhedron because its faces are polygonal regions. So you can see there's triangles and rectangles and squares. B and C are not polyhedral because, well, B is curved and C has a big old hole in it. Okay? A polyhedron is convex if the line segments connecting any of the 2 points is contained inside the polyhedron or on its surface. A polyhedron that is not convex is called concave. So you've had these before. Okay, you've seen these before. So classify the following polyhedra as convex or concave. What do you think about number one? That's right, it's convex. What about number two? It's concave. Now all line segments are inside or on the surface. And what about three? It is convex, just like number one was. Okay, so you really like how you had regular polygons, you have regular polyhedra as well. So regular polyhedra have lateral sides that are perpendicular to its bases. These are examples of regular polyhedras. A regular polyhedron is convex, whose faces are congruent regular polygons, the same number of which meet at each vertex. The ancient Greeks proved that there are only 5 regular polyhedras: tetrahedron, cube, octahedron, dodecahedron, and isohedron. So those are the only 5 that you can have. So the tetrahedron has 4 triangle sides. Cube's got 6 square faces. Octahedron has 8 triangular faces. Dodecahedron has 12 pentagonal faces, kind of like a soccer ballish. And an isohedron has 20 triangular faces. Okay, so you see these a lot in nature. Another content standard here. Don't know what grade it is. So there's a semi-regular polyhedra. Semi-regular polyhedras have 2 or more different types of regular polygons faces. All right. So the faces of this crystal are squares and hexagons. The crystals too developed as flat, regularly shaped faces naturally without the help of machines or people. So it's semi-regular polyhedra. And here they are. And we're going to skip that. Pyramid is a good one. I like pyramids. Pyramids are, you think of the Egyptians, right? The Egyptians' pyramids has a square base and a triangular side. Another good example of a pyramid would be one that, like in Las Vegas, the Luxor Pyramid is an actual replica. Okay, think of the base of the pyramid can be the polygon. Okay, so pyramids are named according to the shape of their bases. So you've seen spires in churches, right? Those are pyramids. So these guys are all right, or excuse me, 1, 3, and 4 are right pyramids. Okay, number 2 is what's called an oblique pyramid. You can have oblique polyhedrons as well. All right, the sides are not isosceles. The vertex that is not contained in the pyramid's base is called the apex. So determine, take a moment, let's see, can you determine these pyramids? Yep, that first one's a triangular pyramid. Oblique square pyramid. Pentagonal pyramid. And how many sides does that last one have? Hexagon, so 6. So the other thing you have is you have prisms, right? They're another very common type of polyhedron, all right? So you name prisms based on their bases, and they have 2 parallel bases. So you can see that you have a triangular prism, quadrilateral prism, hexagonal prism, pentagonal prism, rectangular prism, right? So that's how you get them, all right? And let's move through that. These are natural oblique prisms. You can see the one on the left. It's pretty cool. Another thing you have is cones. Cones and cylinders are circular parts of pyramids and prisms. So you also have an apex. So cones are basically like circles. The base is a circle. So you can have a right cone, you can have a oblique cone, right? Your vertex is at the tip. Cylinders, you can have a right cylinder, an oblique cylinder, and then spheres, like the Earth. Okay, spheres have radius, Okay, they have diameter. There's a thing called a great circle, which is the biggest circle you can draw in a sphere. That's pretty cool. There's really not too much. So you talked about, you guys should know about latitude and longitude, so I'm going to skip that. We're not really going to talk much about that. Um, I don't think I really need to talk too much more on this kind of stuff. This is kind of just a brief overview. Please take a look. I noticed that the notes are goofed up, and I'm sorry. Maybe on Blackboard a better copy is there, but something got lost in translation. This is a crazy time right now. Keep chipping away at this. A couple people have asked about our test. I don't know what we're going to do about the test. I might make it like a Google form that it might be multiple choice, or you might have to answer some questions. I don't know what I'm doing yet, but I will let you know. So hang in there, be safe, and hopefully I'll see you soon.